What if machines could think, learn, and reason just like humans? What would that mean for our future? Imagine a world where artificial intelligence, or AI, isn't just programmed to perform specific tasks, but can understand and reason at the same level as a human. This is the concept of artificial general intelligence, AGI. Unlike the more familiar narrow AI, which excels at specific tasks, AGI would be able to perform any intellectual task a human could. The path to AGI isn't straightforward. Scientists and researchers are exploring numerous approaches. Some are working on symbolic AI, where AI systems use symbols to represent the world and logic rules to solve problems. Others are developing neural networks, AI systems inspired by the structure of our brain, with interconnected nodes or neurons that process information. Then there's the cognitive science approach, where we study the human mind to understand how we think and solve problems, using this knowledge to develop AI systems that mimic human intelligence. The potential benefits of AGI are numerous. It could automate tasks currently performed by humans, freeing us up to focus on more creative and productive tasks. It could solve complex problems beyond human capabilities, leading to breakthroughs in fields like medicine, science, and engineering. AGI could analyze large amounts of data and identify patterns difficult for humans to see, leading to better decisions in business, finance, and government. But with great potential comes great risk. AGI could become so intelligent that it surpasses human control, posing a threat to humanity. It could lead to mass unemployment by automating jobs currently performed by humans, causing widespread economic dislocation. AGI could even be used for malicious purposes, like developing autonomous weapons that could kill without human intervention, posing a serious threat to global security. As we stand on the precipice of this new frontier, it's important to ask, how do we approach the development of AGI? It's crucial to carefully consider these potential benefits and risks before proceeding with AGI development. There's no guarantee that AGI will be beneficial to humanity, and there's a real risk it could pose a serious threat. Safeguards must be developed to ensure AGI is used safely and responsibly. Imagine an AI that uses symbols to represent the world and follows logical rules to solve problems. Welcome to the realm of symbolic AI. Symbolic AI, also known as good old-fashioned AI, deals with the manipulation of symbols to mimic human reasoning. It's like playing a game of chess, where each piece symbolizes a certain value and every move is dictated by a set of rules. In symbolic AI, the world is represented in a symbolic manner. Just as in our minds, a cat is not just a combination of pixels in an image, but a symbol representing a feline creature. Symbolic AI sees the world as an array of symbols. These symbols are manipulated according to logical rules, enabling the AI to solve problems and make decisions. So what makes symbolic AI tick? It's the principle of symbolic logic. For instance, if all apples are fruits and X is an apple, then logically X is a fruit. Simple, isn't it? But imagine applying this logic to a vast array of symbols and rules. That's what symbolic AI does. Symbolic AI has several advantages. It's transparent, meaning we can trace the AI's decision-making process, something that's not always possible with other forms of AI. It's also good at tasks involving rules and logic, such as playing chess or solving mathematical problems. However, like all things, symbolic AI has its limitations. It's not very good at learning from experience or dealing with ambiguous situations. It needs clear-cut rules and symbols. For example, it might struggle with understanding natural languages, which are full of ambiguity and exceptions to rules. But despite its limitations, symbolic AI has practical applications. It's used in expert systems, which are designed to provide advice in specific fields like medicine or law. It's also used in automated reasoning systems, which can prove mathematical theorems or troubleshoot technical systems. While symbolic AI has its merits, it's not the only path to AGI. But it is an important stepping stone. It is a testament to our ability to create systems that can reason, albeit in a limited context. And who knows what the future might hold? Perhaps a blend of symbolic and other forms of AI will end up paving the way to AGI. What if we could design AI that mirrors the structure and function of the human brain? This thought brings us to the concept of neural networks, a fascinating approach to developing AGI. Neural networks are designed to mimic the human brain structure with interconnected nodes or neurons that process information. Imagine these neurons as tiny information processing units, each capable of making simple decisions. Combine millions of these, and you have a complex network capable of learning and making decisions just like a human brain. So, how do neural networks work? Well, they learn by adjusting the strength of connections between neurons. When a network is trained on a set of data, it tweaks these connections to find patterns in the information. For example, a neural network trained on images of cats and dogs would eventually learn to tell the two apart. And the best part, once a neural network is trained, it can apply what it's learned to new data. This is where we see real-world applications of neural networks, from voice recognition in your smartphone to self-driving cars. These systems are all powered by neural networks that have learned to understand and interpret complex data. But it's not all smooth sailing. Neural networks have their limitations. They require a large amount of data to train effectively, and they can be quite complex to understand and interpret. Plus, they can sometimes make mistakes when faced with data they haven't seen before. Despite these challenges, neural networks have made significant strides in the field of AI. They've given us systems that can recognize faces, understand speech, and even diagnose diseases. And while they're not perfect, they're continually improving as we refine our techniques and understand more about how they work. Neural networks bring us a step closer to AGI, but there's another approach that delves even deeper into the human mind. But we'll save that for the next scene. To build a machine that thinks like a human, shouldn't we first understand how humans think? This question leads us to the third approach to developing artificial general intelligence, or AGI, cognitive science. Cognitive science is an interdisciplinary field that studies how the human mind works. It draws from psychology, neuroscience, linguistics, and other disciplines to understand how we perceive, think, and solve problems. The idea is to use these insights to create AI systems that mimic human intelligence. One of the key principles of cognitive science is that human behavior is driven by internal mental processes. These processes include perception, memory, and decision-making. So instead of just programming an AI to respond to inputs in a certain way, cognitive science tries to replicate these internal processes. For instance, cognitive science might inform the development of an AI that learns in a similar way to a child. Just as a child learns through experience and interaction with the world, the AI would also learn through trial and error, gradually building up a knowledge base. There are many benefits to this approach. For one, it could lead to more flexible and adaptable AI systems. These systems might be better able to handle unexpected situations or to learn new tasks without explicit programming. However, cognitive science also has its limitations. The human mind is incredibly complex, and we still don't fully understand it. And even if we did, it's not clear that we could replicate its workings in a machine. Furthermore, this approach can be time-consuming and resource-intensive. Despite these challenges, cognitive science has already had a significant impact on AI. For example, it has informed the development of AI systems that can understand and generate natural language. These systems are used in voice assistants like Alexa and Siri, and in automated customer service chatbots. Each approach has its strengths and weaknesses, but together, they could pave the way to AGI. As we continue to learn more about the human mind and how to replicate its processes in machines, we move closer to the possibility of creating truly intelligent AI. We've journeyed through the different paths to AGI, but what does this mean for our future? As we venture into the realm of artificial general intelligence, or AGI, we're exploring uncharted territory. We've discussed the various approaches to achieving AGI, from symbolic AI, which uses symbols to mimic our logical reasoning, to neural networks, which emulate the structure of our brain, and cognitive science, which seeks to replicate the way we process information and solve problems. The potential benefits of AGI are extraordinary. Imagine a world where mundane tasks are automated, freeing up time for humans to engage in more creative endeavors. A world where complex problems, currently beyond our comprehension, are solved effortlessly by AGI, leading to unprecedented breakthroughs in medicine, science, and engineering. Or a world where AGI analyzes vast amounts of data to make informed decisions that surpass human capabilities, revolutionizing sectors like business, finance, and government. But as with every powerful technology, AGI comes with its own set of risks. The thought of AGI becoming so intelligent that it surpasses human control is daunting, to say the least. We need to ponder the economic implications if AGI automates jobs currently performed by humans, potentially leading to mass unemployment, and the possibility of AGI being used for malicious purposes, like creating autonomous weapons, is a chilling prospect. These potential risks and benefits underscore the need for careful deliberation and development of safeguards. It's crucial that we strike a balance between harnessing the immense power of AGI and ensuring its safe and responsible use. We must navigate this journey with caution, constantly evaluating and re-evaluating our steps. The future of AGI is uncertain, but one thing is clear: it's a journey we must navigate with caution and responsibility. Thanks for watching. Don't forget to like, share, and subscribe for more insightful content.